Functions defined by integrals. We're given some function g of x, which is equal to the integral from 0 to x for f of t dt. The graph that is pictured is the graph of f, so I definitely want to remind myself that I'm looking at the graph of f. One thing that can make function defined by integral problems easier is to set up the relationship between f and g and their derivatives at the beginning. So g of x is the integral of f. G prime of x means that we're going to take the derivative of an integral where the upper limit is a function of x. We plug that upper limit into the integrand times the derivative of the upper limit, which in this case is 1. And then g double prime of x is equal to f prime of x. And then the first question says find g of 0. So we're going to plug in 0 for all the x's. G of 0 is the integral from 0 to 0 for f of t dt, which is 0. The upper limit and the lower limit are the same. Then we're going to plug in negative 1. G of negative 1 is equal to the integral from 0 to negative 1. We're evaluating an integral using the sum of the signed areas under the curve. Then we want the lower limit to be the smaller number. So we're going to flip the limits and we're going to multiply by a negative. And then we're going to find the area under f from negative 1 to 0. And that's this area of this triangle. It's a 2 by 1 triangle. So then negative 1/2, the base is 1, the height is 2. We can simplify, but this is free response, so no need to simplify. If we ended up having to use this number later on, that's where we would want to definitely simplify. G of 2 is the integral from 0 to 2 for f of t dt. So then that's going to be the area of this semicircle or quarter circle. So then 1/4 pi r squared, where the r is 2. And then the last value is going to be g of 5. The integral from 0 to 5 for f. Whoops. Let me pull that back up. The integral from 0 to 5 for f of t dt. I don't know why that happened. So then that's going to be that quarter circle. And then we have this triangle. And then we also have a trapezoid. And the triangle and the trapezoid are going to be below the x-axis, so it's going to be the negative of that area. So we have that 1/4 pi r squared, where the r was 2, minus 1/2. The base of that triangle is 1. The height of that triangle is 2. And then minus 1/2 base 1 plus base 2 times the height. And base 1 is 2. Base 2 is 1. The height is 2. And again, if we were going to use that somewhere else, then we might simplify. So we may end up coming back and simplifying this in a later part of the problem. The next part says find all values of x on the open interval at which g has a relative max. A relative max for g is where g is increasing then decreasing, which means g prime would be positive and then negative. G prime, which is f. And we know that based on the relationship that we set up at the beginning of this problem. So we're looking for f to change from positive to negative, and that happens right here at x equals 2. So then g has a relative max at x equals 2 because g prime, which is f, changes from positive to negative. Part C, find the absolute min on the interval from -1 to 5. So if it's absolute on a closed interval, that means we're going to do the candidates test. This is x. Now we're finding the absolute min of g, so we want to see the y values of g. My endpoints are -1 and 5, and I need the critical values of g, which are g prime equals 0 and g prime is f. So then we're looking for f equal to 0. One of the values is at x equals -1, which is already in our table because it's an endpoint, and the other value is at x equals 2. And then we're going to calculate y values. We don't even need to calculate the y value at x equals 2 because in part B we found out that x equals 2 is a relative max, and if x equals 2 is a relative max for g, then at x equals 2 can't be the absolute min. It's not the smallest value in a small piece of the function. It can't be the smallest value over the entire function. So then we just need to calculate g of -1 and g of 5. G of -1 we calculated in part A. It's at -half times 1 times 2, so g of -1 is -1. And then g of 5 we also calculated in part A. It was this number here that we didn't simplify. So then we'll go ahead and simplify that now. This is going to be pi minus, and then a half times 1 times 2 minus 1 minus is a half times 2 times 3, so minus 3. So then pi minus 4. And we're looking for the smallest y value, and that smallest y value then is going to be -1. So find the absolute min value and the value of x at which it occurs. And with the candidates test, then our table and a summary statement with that table is the answer here. So G has an absolute min of -1 at x equals -1. And then part D, find the x-coordinate of each point of inflection on the graph of G. A point of inflection is where G changes concavity, either from up to down or down to up. That means G double prime will be changing from positive to negative or negative to positive. And that means G prime will be changing from increasing to decreasing or decreasing to increasing. And G prime is equal to F. And since we're looking at the graph of F, then we're going to look at these characteristics. So looking at the graph of F, we're looking for a change from either increasing to decreasing, that happens right here at x equals 0, or decreasing to increasing, that happens right here at x equals 3. So two x coordinates for points of inflection, x equals 0 and x equals 3. And they're just asking for the x coordinate. G has a point of inflection at x equals 0 and x equals 3 because G prime, which is F, and I keep referencing back to F because F is the graph that's given, so that's the evidence that I have. And then I want to make a connection back to G, and the way that G and F are related is that G prime equals F. Changes from increasing to decreasing and decreasing to increasing. And as far as the function defined by integral part, the other problems are essentially the same. Evaluate G Looking for characteristics of G, this one happens to be concave down and increasing. This is a problem that's not really related to the fact that G is an integral. It's a little bit related. This question's about F. And then here's another one. Evaluate, find a relative, max, use the candidates test to find an absolute min, find a point of inflection. So these function defining integral problems are essentially the same.